Hello everyone, I hope you are all in good condition and healthy. Still with me, Party Roseate. At this time I will explain how to operate the raw mill vertical roller mill using the simulator. This is one example for the production process of milling raw materials using a vertical roller mill. To control this raw mill production process, using hot gas from the Hotgas Generator, it is generally operated when we want to operate a new cement factory. At that time the raw meal silo is still empty. So it is not possible to operate the kiln. Before we operate the raw mill, we must first identify the buttons used to start and stop. To start the first time from the top start group, then followed by the groups below it. Then here there is also a button to open and close the damper or to increase the ID fan speed or the separator speed, which is to use the C button like this example, the C button to open and close, by clicking W, when everything is in good condition. During stop all dampers must be in the 0 position. So we have to close everything. Then for the speed ID fan, so before starting this, the speed must be at 0%. Well, we do for heating up raw mill. To operate this hot gas air generator, they use fuel oil, generally use IDO or industrial diesel oil. Next, we prepare to do heating up. The first thing we start is the hot gas line from the mill to the EP, then we click group kiln filter. This kiln filter is the same as dust collector, then we start, but it has a damper whose position is open. The damper is still at 100%, so we have to close it to 0 so the EP fan can run. After start that, the damper must be open first, approximately between 30 and 50% of the damper, then we will adjust the speed and we will gradually increase it. The first time there is no need to open or pull more suction, because what we expect is to warm up slowly. Next, we start the second group for circulation air, by clicking on the raw mill circulation air group, then clicking on the start group. Like this. Okay, let's observe what is running in this circulation group. Again, let me give an example that every time we run the fan ID the damper must be closed, because it is still 100%, for that we must close it first. So later when operating a raw mill or kiln that is related to the ID fan. Before starting it, the damper must be closed. We set the speed earlier to 5%, then we run the fan, then for the speed separator, what we have to observe is the draft, not too high when we want to start the hot gas air generator fire. When you want to start the hot gas generator for the first time, the return valve after this pump must be open 100%, so that when the pump starts there is no oil entering the HAG or hot gas air generator room, then the oil will circulate back into the tank. After we want to start or we setting using the C button near the temperature mill outlet. The hot gas lines are all ready for the heating up raw mill. Then we will start the hot gas air generator by clicking the group button on the hot gas air generator, then we start and we observe the process. During this heating up, we have to do it slowly to raise the temperature. Then after the pump motor runs, then we open the use of the oil. If we lower it by 1%, it can use about 70 to 100 liters of oil per hour. When we want to add oil, by reducing the return valve, only 1% can use 78 liters per hour. We increase it again so that the temperature can rise. We try to increase by 1% again, we lower it to 98%. The temperature at the inlet is 198, then at the outlet it is still 52 degrees Celsius. So that at the time of feeding, the inlet temperature is maintained between 300 to 350 degrees Celsius. Then at the outlet the temperature is approximately 85 to 95 degrees Celsius. This is for the damper. We only open it up to 100% first for the mill fan, during heating up and mill operation. We will only play on the speed ID fan. We add another 2% of the oil usage. The oil usage has reached 310 liters per hour. Then the temperature for the inlet is around 340 degrees Celsius, the outlet is 80 degrees Celsius. We first prepare to run the feeding system. What is meant by group feeding is not the material that will be included, but the bucket tailings reject material, meaning that the coarse material will be milled back into the mill later. Here we prepare dough to start. We click group feeding, then we start. Every time we carry out activities for the start group, we have to observe the process, which is which tool runs first. This inlet mill is equipped with a double flap with a motor, then belt conveyor running, then a bucket for external tailings, then gate outlet mill running. After this is all running, we return to the raw mill display group. From this raw mill group we can see several parameters and equipment for the mill, then for the hydraulic pump for the roller. Before we start the mill later, the hydraulic pressure must be prepared, and at the beginning we have to set the hydraulic pressure to a minimum or 30 bars. Because there are several operators doing to start the mill for the first time, such as an earthquake, it is a collision between the roller and the table. That's what will cause damage to the parts in the mill. We really avoid this, especially since it's to control the operation of a very new raw mill, meaning that it has never been operated before. Because the feed will directly enter the material, the minimum setting is between 50 to 100 tons per hour. Because the capacity of this mill is 600 tons per hour. Okay, let's just set 50 tons per hour first, and how much oil we will use later. Before I explain further about how much feeding we put in, how much fuel is used for the operation of this raw mill. Starting from heating up to feeding later, a few days ago I made a calculation, so if to make the composition of the material, we want the target raw meal product later, what we have to know is the composition of the raw material. Those who know are our friends who work at PCM, but we also have to know the contents. Then we calculate using a formula like this. The goal is to determine the composition of the feeding material, for example what percentage is for limestone, what percentage is silica, what percentage is clay, and what percentage of iron sand is this. Then if this target is changed, it will change everything. Then for fuel consumption, I have also calculated, so for example we enter feeding 50 tons per hour, because of the moisture content listed here. Of all the material compositions according to the simulation, I entered the data. This is 8.4% of the total feeding, just multiply how much H2O must be evaporated. Here there is moisture content. If 50 tons of feeding means there is 3.7 H2O or water that must be steamed. That requires approximately 516 liters per hour, then I also calculated how many damper openings we have. So that we have a reference for adjusting the return valve opening related to fuel consumption, how many liters per hour we use like this. For example, I want to feed 100 tons per hour, how many liters we need and how much is the opening of the oil return valve. Alright, we're back to the monitor for this vertical roller mill raw mill control. What should we do, because the suction is less, judging from the low outlet temperature, the high inlet temperature. We add the speed again for the ID fan before we add fuel, we add 10%, after we add 10%, we expect the outlet temperature to go up, we didn't add fuel earlier, the inlet went down. For this outlet mill there is a limit, for limit 1 it is 140 degrees Celsius and limit 2 which stops the HAG Hotgas air generator is 150 degrees Celsius. For that we have to keep the temperature at the outlet mill below 140 degrees Celsius. After this, we see the temperature at the inlet mill goes down. The outlet mill goes up, we try to add more fuel, we increase it. We'll try the calculation earlier, it's about 93% for feeding 50 tons per hour. The temperature at the outlet quickly rise above 100 degrees and at the inlet mill it was over 300 degrees Celsius. We increased the damper opening again. Let's see, this is the temperature at the outlet 120 degrees Celsius, the valve opening 94% earlier in the calculation of feeding 50 tons with 93% opening return valve and requires approximately 516 oil. Let's try to equate it with what we calculated earlier, at 93 how much the temperature rises. Earlier in the calculation of 516 in this simulation is how much, this is up to 545 degrees Celsius. Then the inlet temperature of 359 at the outlet is approaching limit 1, we start the raw mill group or the mill drive. We observe using the main monitor display to carry out this raw mill operation, so that all parameters can be controlled in this one display. Let's see if the outlet temperature drops drastically, then we pull it or by increasing the speed of the ID fan, from 30 to 40%, we observe that we gradually increase the feeding. With 50 tons of feeding, the vibration is still high, here the bed material is low, meaning that there is less material entering the mill. Since we see the temperature at the outlet is low, we have to add fuel. From 93 to 87% we can increase the feeding to 100 tons, earlier because this 50 tons must be fast, because the simulation speed is 10 times the standard time or normal time. The temperature at the inlet is high and the outlet is low, the mill fan must be increased, because the feeding increases the pull, so that the temperature at the outlet increases and the temperature at the inlet decreases. To control the operation of the raw mill, it is not only the temperature that is expected, but the volume of air, whereas if we use the preheater system, in addition to the temperature, the volume of exhaled air that is driven using the SP fan is quite high, so that the volume and temperature are sufficient for drying and grinding of raw materials inside mill system. Let's just optimize the operation of this grinding mill by using a vertical roller mill. We try to add more fuel consumption, by lowering the return valve to 82 or 5% we lower it, then we add the pull speed of approximately 5% first. Then the damper that goes to the EP must also be open so that what is drawn from the mill system can enter the EP. It can be seen that the bed material is still low, we must immediately add feeding material, because the temperature at the outlet has started to rise. At the inlet it has also gone up. This we add another 50 tons, then we increase more pull or speed mill fan. How much is this mill capable of feeding using a hot gas air generator? Even though this is just a simulation, we can use this simulation to operate the mill, at least a standard operation is made. So to run this raw mill for the first time, what are the preparations? Then later we can make in this simulation such as troubleshooting, why does the mill vibrate and there are other disturbances? Why is the percent LSF so high it can't match the standard and so on? So it can be done in this simulation various kinds of trouble and will not damage the tool, because this simulation is not directly connected to the factory. It can be seen here that the moisture content of the product is still above 1%, while the target was below 1%. As much as possible approximately 0.5% H2O from raw mill products. The percent LSF has also not been achieved, because it has 98% targets. Because we are still managing fuel consumption and increasing feeding. After approaching the optimum, we will look at raw meal products. It takes about 1 to 2 hours. We're back again to raise the temperature by adding suction. This is already 70%, it's quite high actually, for feeding 150 this is quite high, and later if for example the temperature is high it keeps at the inlet and at the outlet it can't go up, we have to open it even a little for the circulation damper, we try to open only 5% to 10%. We observe not to let the temperature in the dust collector also rise, if it is too high, the hot gas does not enter the mill but hot air enters the dust collector. The delta pressure is 8, then the bed material is still low. Okay, let's add more feeding. We add 50 tons to 200 tons per hour. With the use of oil that was still lacking, we added another 82, which is about 5% again to 77%. So it can be seen directly, the product can be seen directly, no need to check from PCM, no need to wait. Then how many tons of product per hour have been entered into the silo? After the raw meal products are entered into the silo, there will also be blending. So you can see the changes or comparisons. It's high, because of what? By going up the feeding, but we forgot to add hydraulic pressure. This is an example of a problem, because the bed material has high hydraulic pressure and low hydraulic pressure, vibration occurs, but if we increase it immediately, the mill will most likely not stop. We raise it first, while observing, with a high bed material, the hydraulic pressure must be increased, whether the bed material goes down and then the vibration also decreases. This is all troubleshooting, right? So it's not just an early start, but there are troubles. If this is done in the field or actually processed with 10 vibrations, it's like there was an earthquake or shaking. It can be proven that earlier because the high bed material causes vibrations. Once the pressure is increased, the vibrations will also decrease. We raise it again plus 10 bars, so that the bed material goes down and the vibration also goes down. We increase the feeding to 250 tons per hour from 200 tons. Every time we add feeding, we observe the parameters. With the addition of feeding, the material of the bed, which was thin, will most likely increase. Currently it is 60 millimeters. Please note that for this raw mill or vertical roller mill operation, the normal bed material is 100 to 120 millimeters, then for mill vibration it is kept below 4 millimeters per second. Let's see that the outlet temperature is around 60 degrees Celsius. We add more fuel consumption so that the feeding can increase from 77 to 72%. This is for the speed. It is already 75% for the mill fan speed. We add 10% so that it can be quickly pulled to the outlet. We observe, the moisture content is still high. We can't add feeding yet. Before we had to add fuel, add 5 to 67%. If we want to add feeding, we have to prepare the fuel. With the addition of feeding earlier, the hydraulic pressure is increased, the inlet temperature is above 400 degrees and the outlet is still fluctuation, meaning that the hot material and gas in the mill is unstable. Well, let's continue to increase the speed of the mill fan, so that the temperature at the high inlet can be drawn into the mill. We add more fuel consumption, because it can be seen here that the material is still low in bed material. We increase the feeding 50 tons. With the addition of 50 tons, it means that fuel must also be added, so that the moisture content is not too high. Fuel consumption is approaching 3,000 liters per hour with a feeding of 350 tons per hour. To optimize the mill, which is 600 tons per hour, by using a Hotgas generator, it is possible that it is only 400 tons per hour. Considering that the mill fan damper opening is 100%, then the speed has reached 90%, but the temperature at the mill outlet is low, resulting in moisture content is high, so that we do not pursue many products, but product quality. Because this material was first used in the kiln, so later if the product quality is not good, so that the operation of the kiln is also very disturbed. The feeding is 400 tons per hour with a moisture content is still 1.2%, hopefully it's below 1 or 0.5%. Here, the bed material goes up, we have to immediately increase it 10 bars, we can see the bed material is still going up, with 350 tons per hour feeding, the vibration goes up, we have to increase the pressure immediately. Let's observe the vibration. If it drops, then the bed material is close to normal operation. We just look at the quality of the product. We try 100% so that the inlet temperature drops. We can add more fuel, so that the material is not too moist. We only use 3,000 liters per hour for oil, and feeding can be 350 tons per hour. We observe the process. This moisture content is 0.0 with an outlet temperature of 87. What should we do? Try lowering the speed of the separator so that the residue increases slightly and the product increases. The residue increases accordingly is 12 to 14%, then for the moisture content is very low is 0.0. We can add feeding. After feeding we increase it to 400 tons per hour. Then we set the speed of the separator to 40%, the residue which is 90 microns is in accordance with the standard 12 to 14%, but here the product quality for LSF is still above 102, then SM and IM conforms to the standard only its LSF is high. Then for the moisture content is still above 1%, we have to optimize for this operation. Most likely the feeding does not need to be added because the air flow is not enough, but only the temperature is sufficient. Both for heating the material in the room and for conveying gas from the mill to the cyclone separator, what we have to improve is the quality of the product first, namely the weighing feeder setting. Let's try to set it and then see the change in the quality of the product. Let's try to increase the sandy clay by adding clay. Okay, let's try it first. The LSF can go down or not, then click OK, the LSF changes start to go down, then the SM changes are not too much. By changing only one parameter, this LSF is in accordance with the target between 97 to 995 LSF, the SM is in accordance with the IM standard as well, so what we have to improve is the moisture content, so that the material entering the silo is not damp. What we have to do is increase the temperature. Because the temperature at the inlet is high, let's try to add it again to 100%, we increase the speed to 100%. Okay, let's optimize it. If feeding 400 tons per hour, the material still has moisture content, it should be reduced first so that the product produced is as we want or according to the standard we want, so that when the silo is fully filled, it doesn't need to be between 40 to 50% only. After reaching 40 to 50% stock silo, just stop this raw mill. Then wait when the new road kiln is started using hot gas from the preheater system, which saves the fuel we have used so far 3,276 liters per hour. This raw material moisture has an average of 9.8%, then this product is still 1.8%, this is expected to be 0.5%. Because this is still too high and we can no longer add fuel, whether we like it or not, we have to reduce feeding, so that the quality of the product can be achieved. Let's just decrease 10 tons for feeding, earlier from 400 to 390, let's observe the vibrations are 5, hopefully below 4, this is because we reduced 10 tons of vibrations a little bit up. Because the bed material is also in accordance with operational standards, 100 to 120 mm thickness of the material. For example, if this is a thin bed material, the hydraulic pressure can also be lowered. Because we control the production process of this raw mill system with a hot gas air generator, it's not as much as the number of products but how optimal the raw mill. This operation uses a hot gas air generator with a mill capacity of 600 tons per hour. How much can be achieved optimally? Approximately 380 tons per hour. Because the moisture content here is still quite high, we lower another 10 tons for feeding. If the vibration increases, the hydraulic pressure must also be lowered. LSF is all in with its standard, 380 tons of feeding, then the bed material is still normal. Now, wait until it reaches 40% or 50%. Why does it have to be 50%? Because for continuous blending like this, the blending can be effective if the raw meal stock is above 40%, below that the blending effect is not good. Okay, the vibration still won't go down, let's lower the hydraulic pressure to just 90 bar, hopefully it can go down, now it can go down. It can be seen that all the quality is close to good. Just because the outlet can't go up, we try to add another 1% of the oil usage. Hopefully this can help to reduce the moisture content of raw meal products. Hopefully it can drop below 1%. With feeding 380, the product is approximately 346 tons per hour. 80 to 90 degrees moisture should be able to drop, hopefully below 1. If it doesn't work, let's try adding a little more for the fuel consumption. How to add it slowly from 57 to 56 return valve. OK, temperature outlet mill about 80 degrees, and 0.6% of moisture content, so the conclusion was that the feeding was 380, then the oil consumption was approximately 3,432 liters per hour, then the mill vibration was still normal, the bed material was also still in normal operating standards, with a hydraulic pressure of 90 bar. The outlet temperature can be maintained and the separator speed is 40%, then fan IDs are all at 100%. For raw mills operation that use a vertical roller mill and use hot gas from the Hotgas Generator, I'll suffice it here. Hopefully this video material is useful for you. Thank you for watching this video. Don't forget to subscribe, like, comment and share with friends who need it, and see you in the next video.